yeah, this is gonna be nice. You have all this good expectation here. Well, it is damn expensive getting a haircut in Copenhagen. Mostly when you are a Tanzanian like me. It is a hassle doing all this preparation of calling the saloon, of grabbing different transportation just to go to the inner Copenhagen to get a haircut. At the end of the day, every time I go get a haircut, it costs a lot of money, it's time consuming, and it's just, the return of interest is just so low. I am not satisfied. Right? This story is actually quite common in our many business area. My talk here is how can you build a sentiment model, or in that sense, any model, very fast, scalable, and without so much hassle. Because actually, at the end of the day, it's all about business value. It's all about the return of interest. At the end of the day, when I take all this hustle going to the saloon, I just want to look good. And that's the same thing with machine learning. So this, we had this problem at IF, where we have a team called the end-to-end team. It's part of the customer service. Its job, or their job, was to classify which of our customers were not satisfied with us. And then from there on, we need to see, okay, those customers that are satisfied with us, they will be taken to another pool, like upsell. So they will be sent to outbound, where we can call them because they're happy. Maybe they're more likely to buy more products. What happens if you try to call a customer who is not satisfied with us to buy more products? That's terrible. So we need another strategy for those who are not happy with us, going to another system of people trying to rescue them. There is where text analytics plays a huge role. So as you can see there, the problem is quite easy. So it's just which customers are happy with us, which customers are not happy with us. And how do we need to do this? Let's look at text. How do our customers express themselves when they're happy with us? How do customers express themselves when they are not happy with us? And then can we use that to build a simple model to be able to deal with this business value, business problem, and produce so much value. So this is actually a simple model that I came up with in the beginning, because we wanted to do something very fast and put it in production very fast. So there was no time for the whole charade, the whole drama of going to call the saloon, take the bus, go there. There was not that time. Yes, I am not dissing that infrastructure and the good architecture is not important. It's very, very important. But sometimes you need something very fast out there bringing value. Do you agree? Okay, so that is actually a simple model. You have a business need, you have a kind of domain knowledge, I will come back to this, and then you have this machine learning, and everything that you see here is a macro service, small system that are specializing in doing specific things, joined together to bring value. So in this case, it's easy to maintain, it's easy to deploy, and everything just works. So I had some kind of examples here. So I know people say to not do a live demo or anything. I'm just going to do a live demo because once you see this, then you can understand what's going on behind the scene. So I will keep on speaking as I kick things into motion. So I will just kick that one into motion, and then I will kick this one also into motion. So they are all kicking in. Okay, so right here I have just spin it up an application, loading my model, putting it in a deployment on my local server right now, so I have no problem. And just like that, I have another, I can just go back here, so go here, so go like this. Hey, I know I am terrible in front end, but that's not my area. My area is at the back end, but then this is something I could spin up as fast as I could. I am not a Java programmer. But hey, look what is going on. So our team could receive some text and quickly pass it here, or more in an API. This is just to show you. And then they will quickly receive the response on whether something was positive or negative. So that's an example. So I send in a smiley, and a smiley is actually that good. And as you can see, this model was made to be able to be retrained. So you could see it asked, did I get that right? And I said yes. But we could do even something more awesome. I just will take something here. I haven't seen this data before. So I will just grab these guys here. And then I will just drop it here. And I'm expecting this to be pretty much negative. Let's see, and it is 91% probability that is negative. So our model is there doing its job, classifying the text as it should. So as you already get an appetite with what is going on or what is to be expected, I will take you behind the scene on how this tool was quickly spin up. Okay, and of course, I will not start bombarding you with words you don't need to know. All this is available on my GitHub. You can just go clone the repo, do whatever you want. And this model was built in Danish language, and you can actually build in any language if you follow the template that I've made it available for everyone. Okay, so here are the things that I've learned, which I'm just going to quickly show you as time clicks down. So from here on, I will just go with tempo, 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 tempo. Okay, let's go. So this is the first thing when you do a project like this is you need to understand your data. First, how did I collect my data, you will ask? Well, because I wanted to make this project open, I wanted to use an open data. So for my case, I have used Trustpilot data, because in Trustpilot there was really good data there, which I could simply go in, gather it around, and spin up a model. So as you can see, this is the data that I have. Some guys write a certain comment and they give a score of 1 to 5, where 1 is very unsatisfied and 5 very awesome, just like what you guys saw here. So you can see a 1 star there, someone is not happy, right? So in the aim here is just feed this to a machine, tell them how do people write when they're excited? What do people write? How do they write when they're not happy, right? And let the model figure out how to do the classification. So as quickly as I go here, the things that I learned is that the data is unevenly distributed because we are Nordic. We tend to be more happy with our systems. So you can see the probability, whenever you train here, the model will be biased towards the positive if you don't do anything about it. So by just looking at this, you know, okay, I need to downsample something. I need to use a model that maybe will take care of unbalanced data. Maybe I should do weight, make the negative weight more or something like that. Just looking at your data, you'll begin to know what is needed in the coming steps. And just like that, you can begin to look at which words occur quite frequent. And as you guess, some of the words appeared really a lot. And you go like, what in the world is going on? And then if you look at this kind of words, it's a word like end, and it's a word like I. These are the words that are called stop words. They are noise to your data. So somehow you need to remove all these stop words in order, because they appear both in the positive corpus and in the negative corpus without adding so much value. But at the same time, there are some kind of stop words which are necessary in order to know whether someone is satisfied or not satisfied. Words like not. It's one of the stop words, but I need to keep these stop words because of my need. And here's where the domain knowledge plays a huge role. And because I was using Trustpilot data, I knew words like service, packages, post office will be just noise because they appear a lot of time. And this you can only notice if you try to visualize your data to see what kind of words that are appearing a lot, like delivery. You go like, this is just going to cause mess, take it out. But this requires domain knowledge of what is it that you're trying to do. Okay, so from there on, after doing some cleaning, you could see still we have some words that are stop words, but they are necessary stop words. Like you could see, I will just change to this. So you could see the word not appears in the positive corpus, but you can see it's bending more towards the negative count, which is awesome. And then you can see the word like fast as something very positive. So from there on, I will just go really fast here. So why go about build a sentiment model while there are some cool things already there? So if you're from Denmark, there's this one here, from Finn Nielsen from DTU. He used lexicon scoring, a way to do sentiment analysis. Well, it's already there. Why don't you use it? Well, first of all, it works, as I showed here. I just had a simple sentence, I hate Excel. And then, of course, I do. I really hate Excel. Don't say that to Microsoft. But I hate everything about Microsoft. I didn't say that. Okay. I take that back. Okay, so from lexicon scoring, you have hate as a minus, down face smiley. I don't know if you call it smiley or a saddy. Face gets a -2, and depending on what kind of literature you're following on calculating sentiment analysis, this one will end up into a negative. So as you can see here, the model is quite good, 71% accurate. But the problem is, with lexicon scoring, if you have a negation followed, if you have sentences that have negation, you will never be able to catch that. So if you said, I don't like pizza, it's becoming a negation. But, it was not bad. In Danish, I will take this one in Danish. Det var ikke dårligt, it was not bad. Ikke is negative, dårlig is negative, together they're negative. But in sense, it's actually positive, right? So there is where machine learning becomes really good. So an example of machine learning, a simple model, as I am testing it here, right there. With a simple machine learning, you have an accuracy of 92. Pretty damn cool. And this is not deep learning. This is simple logistical regression. A simple logistical regression with, of course, cool stuff, feature engineering, put that aside, but it's still a logistical regression giving you 92% accuracy. Of course, you will ask, have you tried other tools? Yes, I have tested dozens other models. I have tested deep learning models right there, convolutional network, everything. Yes, they are really powerful, but I just had my CPU. I don't have GPUs. So I needed something simple, something fast. And there's where sometimes you just need simple tools, logistical regression, a very fast way to solve a problem, because at the end, of the day, I am going to the salon. I need just a haircut. Right? So what did I do? Well, I went and bought my own shaver. So right now, every time I feel like being a bit sexy, I just go and cut my hair. I do it myself. And this is the whole point. You don't need sometimes big guns, a big network and infrastructure or anything. Sometimes the simplest solution is just on your fingertips. And this is what I'm trying to sell you. Thank you.